Hello and welcome everyone in my series of machine learning algorithms with implementation in RStudio. In this video, I am going to demonstrate you the support vector machine algorithm for classification problem in RStudio. If you have not studied my earlier, referred to my earlier video on support vector machine, I request you to please go through the window which will give you a clear understanding as how the support vector machine algorithm works. I had discussed that support vector machines are working both for classification as well as regression problems, right? So particularly in this video, I am going to discuss about support vector machines for classification problem with some data set related to heart patient prediction of heart disease for patients. Now there is target class. There are two possibilities that yes, the patient will have heart problem or the patient does not have a heart problem. It depends on other parameters such as age, chest pain, blood pressure, cholesterol and fasting blood sugar. So these all parameters are contributing to determining whether the patient will have heart disease or not. So let us get started by including the library files. So the library files which we require here is E1071, E1071, and then we of course we require the caret class, caret, and in case we want to plot some graphs, then we will require ggplot2. Okay. So let us include all these files and then let us read the data. So a data frame called hard data has been created containing 303 observations of 6 variables. So let us see the structure of the data. So if you see the structure of the data, we realize that all the parameters or all the attributes are of type integer. Now in this case, I want the target class to be a factor variable because it is of two levels, that is 0 or 1. Okay. So I want to convert this parameter, that is target class, into a factor representation so that it indicates the two classes which we are aiming for, which we want to get the results, right? So let us convert it and then again see the structure of the data. So now yes, the factor, it has been converted into a factor variable of two levels, right? Now let us split the data for model training. Okay, splitting data for model training. So let's say my data, I am going to convert my sample into two types, or let's say two partitions. That is, I want to allow the replacement is equals to true, and of course the probability that how much portion will be your training data and how much will be testing data. Let's say for example, we are considering 80% training and 20% testing. So here my first portion will be for the training data, that is the split data is equals to 1 including all the columns, and test data is equals to the heart data, the second split, okay, second portion of the split, okay, is equals to 2 including all the columns. So my training and testing data has been created, data frames have been created. So training data contains 234 observations and testing data contains 69 observations. So let's create the model. Let me give the name of my model as my model, and the function which we are going to use is svm, where we are going to predict the target class. Let's consider all the parameters. So I'm just putting a dot here because it will consider all the parameters, and my data is the train data. Okay, so based on the training data, we are going to train our model, and let's see, we wish to see the summary of my model. Let us have create the model. Yes, model is created, and let's see the summary. So it is a classification type of a problem, okay, not a regression. The kernel, if you remember my theoretical portion, I have discussed that there are different kernels, radial, polynomial, sigmoid and linear kernel. So when we have not mentioned any specific kernel, so by default it is taking the radial kernel. Now support vectors created are 164. So what are support vectors if you remember? So between the two classes, if we want to find out the marginal distance, now to create that marginal line, we draw the line touching the points. Okay. So those points which are touching for creating the marginal distance are our called as the support vectors. So how many support vectors are being created? 164 support vectors are created. So let us see how our model is performing on the training data. So let's predict the model. So data is equals to train data. Okay, and let's see how it is performing the prediction, how well it is being able to learn, right? So train data, so this is how it is giving. For some random values it is giving us zeros and ones, but out of so many data values it is very difficult to understand. So better is that we can use a table type of a structure to understand that how many are correctly predicted and how many are not correctly predicted. Okay, so we will create a table using the table function, and the table will be created of predicted versus predict. Sorry, yeah, actual is your heart. Sorry, your train data class, target class. Right? Okay. So we wish to see the table. So table for training prediction. Let's see. Predict. Let's see. Okay. Yeah. So we have already discussed that these are the actual 86 as 0, predicted as 0. Actually 19 are also 0 but are wrongly predicted as 1. Actually 26 are 1 predicted as 0 which is wrong. 103 are 1 which has been correctly predicted as 1. So which elements? The diagonal elements are the correct ones. So how do we total the diagonal elements? That is, or how, using this data we find out the misclassification error. So how do we find out? That is the correctly predicted divided by the total, right? So this is the misclassification error, and just if you want to execute this sum without doing 1 minus, you get the actual data accuracy, that is 80% accuracy you are doing. Okay. Now let us find out how the model is performing for the test data, right? So my model, how it is performing when my data is the test data. So predict underscore test. Okay. So let's see. Okay, it is performing, but it will be better if we see using a table, right? So let's create a table of predicted is equals to predict test versus your actual is equals to the test data target class. Okay, and we want to see, surely we want to see the table. Let's see how many are correctly predicted. Sorry, predicted is equals to the predict trade. Sorry, yeah, fine. Let's see that there must be some typo error. Let's say tab test is equals to table. We want to perform predicted is equals to predict underscore test, and actual is equals to test underscore data target class. Okay, so let us see for the test data it is performing. Okay, so we have created the table and these diagonal elements are the correct ones. Okay, so now what we can do here is that we can create some plots. Now before creating the plots I want to highlight on something, that is the thing is that, okay, first of all let us compute the classification error for this table, right? So let's say sum of the table values. Okay, so we will compute it. So it is giving around 30%. So let's say only the accuracy is almost 69.3%, right? Now, what we can do over here is that we can create our model with a different kernel, right? If you remember, we have discussed here that the kernel which we were given here is the radial kernel. So that is by default it has been given. Now there are other kernels like linear kernel, polynomial kernel, sigmoid kernel also. So you can fine tune your model by changing the kernel. So if I am changing my kernel to linear, so in that case also we can see what is the error and whether it is performing well or not. Okay. So let us see the for the prediction values how it is performing. So you can see with the linear kernel my error rate has it decreased a little bit. Okay, so 70%. Then you can use a sigmoid kernel also, and in that video, I have discussed also that for which type of data, which type of kernel is the best suited, right? So you can see here the error rate has increased drastically, 45%. So sigmoid is not the fit kernel for this. So let's go for a polynomial kernel. Okay, polynomial kernel. So based on the polynomial kernel also, you can see what is the rate of error or the misclassification error. It is again same as that of your almost your radial kernel, right? So this is how with the kernel trick you can fine tune your model, and of course you can also fine tune your model using the changing the parameters for training and testing data. So if you want to see the plots of, let's say, I want to see a plot of the age versus the cholesterol level. Okay. So let's say heart data of the cholesterol level. Okay. And my data, it will get it from the heart data, and color is equals to target class. So the target class will be shown using different colors. So let's see, if you want to see, zoom it and see it. You can see here there are two target class. The orange represents 0 and the blue ones represent the 1. Okay. Another way you can see the plot is that you can plot the model. Okay, how your model is performing. This is the actual data, right, from heart data. So if you want to see how your model has trained, okay, that is the predicted values on the trained data. So that also you can see of cholesterol versus your age, right? You wanted to see. So let's see the plot here. So with the plot you can see the 0. This is only the class. Okay, and these are cross and 0. The points are being given, right? So these are the data points which are being shown. So this is how you can even change on your kernels, change on the training and testing parameters, see the different types of plots using support vector machine for classification. So in my next video, I am going to demonstrate the support vector machine for the regression model. Thank you. Don't forget to like, share and subscribe to CSC Core Concepts.